Welcome back to this series of nodal analysis. So we have solved multiple examples, okay, of the different circuits using the nodal analysis techniques, and particularly now we are putting focus on the supernodes circuits. So let's have a look at another complex supernode circuit. So what we can see here. So this circuit is quite different from the earlier examples, like this one that we did in the previous video, this one in the another video, and this one. Uh, like this is the first supernode example we did. Was the second, and now we move to this quite of complex kind of a circuit, okay, which basically have quite complex supernodes, okay. So let's just try to write the equations for these supernodes, okay. uh, Now first thing, nodal analysis, identify the nodes in your circuit. So we can see that we have basically this first node, we can label this as v1, okay. Then we have this second node, okay, v2, we can label this as v2. Then we have, okay, this our third node, okay. Then we could have our this node as v4, and then we have basically this node as v5, and the reference is basically ground. So basically we have 5 nodes, so we will get the 5 nodal equations, okay. And we have this voltage sources here, okay, and the value of those voltage sources, okay, that could be any value, okay. For example, let's label this as vs1, okay, and let's label this as we can label this as, let's say, vs2, we can label this as vs3, okay. It could be any value, for example 2 volt, 10 volt, 20 volt, any value, okay. Just for the reference purpose we put the variable values. All right, so once we have such circuit, first thing that we need to check, is there a voltage source between a node and a ground? If we can find that, it means we can get the value of that directly. So which node in this circuit have these properties, that a voltage source is connected between a node and the ground? So we have this one here basically, right, which is connected between node and the ground. So we can write its value directly. So what will be that? So basically V1 is that source value, 2 volt, 10 volt, whatever. Okay, so we got the value of V1. Now we need to look at the other nodes. Okay, so if you look at the other nodes, for example V2, okay, so we notice that at V2, okay, so like this complete node is V2, right? So this is a voltage source that is connected at this node and then this node. So it means like a voltage source between, okay, V1 and V5. This is basically a supernode, right? Now what will be the equation for this supernode? We can easily write. How we can write? Okay, we can say that this supernode equation is basically what? V2 minus V5 is equal to Vs2, right? So this is our equation number 1, this is our equation number 2. So I got basically a supernode. But if you look carefully again, okay, if you look carefully again here, so we can notice that there is another voltage source between the nodes V5 and V4. Okay, so it means this is also making a supernode. So what is the equation for this supernode? V5 minus V4 is equal to Vs3. So this is my third equation. So here we notice one thing. What is that important thing? That we have basically 2 supernodes that are basically kind of interconnecting because of the overlapping node V5. So what we can do here, we can assume that all these 2 supernodes, which are basically kind of overlapping, making my complex supernode. Okay, now instead of writing 2 separate equations for one supernode like we label this V2 and V5 like for this case, and for this case two separate equation, we can write one equation for this complex joint supernode. So let's try to write it down. So let's start from V2. Okay, so what are the currents that could be leaving? So current from this case could be the current through R1 and the current through R4. Okay, so let's just write the current through R1. What will be that? V2 minus V1 divided by R1. Then the current through R4, what will be that? This voltage minus this voltage. So plus V2 minus V3 divided by R4. Okay, with respect to V1. Let's come to V1, V5. What are the currents that could be living from V5? Current through R3 and current through R2. Let's go with the R2. So V5 minus V1 divided by R2. Current through R3, what will be that? V5 minus second node, what is that? 0 divided by R3. Right? Let's come to V4 now. Why? Because this is a part of our supernode. So what are the currents leaving from V4? Current through R6 and the current through R5. Let's write for the R6. So V4 minus, what is the voltage here? 0 divided by R6. Then this current through R5. What will be that? V4 minus V3 divided by R5 is equal to 0. So this is the equation for our complex supernode. So make sure that you do not emit, okay, any current. Okay, you need to move one by one. So we got our fourth equation. So we know that we have 5 nodes, so we left with the last node equation. Which one is that? That is basically your V3 equation. So what are the currents for V3? So current leaving from V3 through R4, what will be that? V3 minus V2 divided by R4. The current through R5, what will be that? V3 minus V4 divided by R5. The current through R7, what will be that? V3 minus 0 divided by R7 is equal to 0. Okay, so this is our fifth equation. So we have 5 equations and 5 unknowns. So now we can use the numerical techniques, okay, to solve these 5 equations simultaneously. So the purpose of this example was to learn that if we get a complex circuit with the multiple supernodes, then how we can write the equation for those cases. Thank you so much.